Okay, Assalamualaikum and a very good day everyone. So in this video, saya nak cover the final part in the force system resultant which is related to finding an equivalent system lah. Okay, so in the previous lecture sebenarnya korang dah belajar macam mana nak kira the equivalent system of an object subjected to multiple forces. So basically apa yang korang buat adalah daripada, let's say you have an object like a beam like this and then it is being subjected to multiple forces like this, so you can calculate the resultant forces in a single force, either it is in the x direction or whether it is in the y direction, or you can also find the moment lah. So basically the black line here indicates a resultant force subjected by these three forces, 1, 2, 3. Okay, so itu korang dah belajar. Tapi the final part of the equivalent system ni is related to how you can locate the point of application. So kita nak tahu this resultant force in the x direction, in the y direction dengan resultant moment ni, where is the point of application? Dekat tengah sini ke, hujung sini ke, tengah sini ke, atau hujung sini? So how do we determine the point of the resultant forces? So looking back to our previous lecture, sebenarnya saya dah minta awak buat this example. So in this example, basically you are required to replace the force and couple moment system acting on the beam by an equivalent resultant force. So kalau tengok dekat beam ni, it is being subjected to multiple forces. Ada satu force of this 4 kN pointed downwards, and then satu ni yang sengit-bengit ni 8 kN, and then jangan lupa there is also another moment acting at this particular direction. Okay, so kita nak convert these three things into an equivalent resultant forces ataupun into an equivalent system. In order for us to convert this whole system kepada satu equivalent system, basically you have to make sure all the forces are in orthogonal direction lah. Okay, so kalau tengok the first force which is 4 kN ni, okay, tak ada masalah because it is acting in the y direction. 15 kN meter ini adalah sejenis moment. Okay, so the direction of the moment adalah clockwise, so ini pun tak ada masalah. Okay, this 8 kN kalau tengok dia sengit-bengit, so you ingat bila sengit-bengit luruskan dia balik ikut sama ada x direction ataupun y direction. So if we want to resolve this 8 kN into the respective x and y direction, let's say kita start dengan x dahulu. Okay, so magnitude of this 8 kN in the x direction, so kita assume this angle to be theta. This theta samalah juga dengan theta kat segitiga kecil ni. Okay, so the magnitude would be 8, sebab dia sebelah dengan theta ni, it would be cos theta. Okay, cos theta in reference to this segitiga kecil would be 3/5. Okay, sebelahan per tentangan. Okay, now that is the magnitude of the 8 kN force in the x direction. Accordingly, you kena cari dia punya force in the y direction. So over here it would be 8 sin theta pula. So referring to this segitiga kecil, 8 sin theta is equivalent to 8 sin adalah tentangan per hypotenuse, 4/5. Okay, now that's done. So the next thing you need to do, kita dah resolve everything in the respective x and y direction. Lepas ni barulah you boleh apply the force summation ataupun you cari dia punya resultant force. Okay, so the first step in solving this kind of problem, so let's say saya buat the first thing adalah saya nak cari the force summation. So it's up to you, you nak buat dekat x ke y ke ataupun z. So in my case, I want to do in the x direction first. Okay, so assuming the rightward direction as positive, so saya nak cari the resultant force in the x direction, which is equivalent to, okay, kita tengok apa benda yang ada in the x direction. Okay, there's one over here in the x direction, magnitude dia adalah 8/3/5. So we put that into our equation, 8/3/5. Ada lagi tak benda yang in x direction? Tak ada. So basically ini adalah the resultant force in the x direction, ataupun bila you tekan calculator you will get a value of 4.8 kilonewton. Betul ke kilonewton? Yes, kilonewton, sebab unit dia dalam kilonewton. Since this magnitude is positive, it means that the direction of this resultant force adalah ke kanan. Okay, so you dah dapat the resultant force in the x direction, and then you move on pergi dekat y direction pula. So assuming the upward direction is positive, So kita nak cari the resultant force in the y direction. So keluarkan segala jadah yang ada in the y direction. Okay, so the first one is this 4 kilonewton pointed downward. So in our equation, it become -4. And then apa lagi yang ada in the y direction? This 8 sin theta ataupun 8 darab dengan 45. It's pointed upward. So it will become positive 8 kali 45. So tak ada lagi benda forces in the y direction. So you sum it up. So using your calculator, you will get a value of 2.4 kilonewton. So since the magnitude of the resultant force is positive, it means that the resultant force in the y direction is pointed upward. Okay, so you dah dapat the resultant force in the y direction. Okay, katakanlah soalan tadi dia extend lagi. So this time around dia tanya where its line of action intersects the beam measured from point O. Okay, so if I were to draw the same system, let's say this beam, okay, this beam saya redraw balik. Okay, saya redraw balik. Okay, so from our previous calculation, we have actually simplified all the external loads being subjected to beam into a single resultant forces. So yang kita calculate tadi adalah resultant force in the x direction. It is pointed to the right. Kita check balik, magnitude dia adalah 4.8 kilonewton to the right. So the magnitude over here is 4.8 kilonewton. And then accordingly, kita juga dah kira the resultant force in the y direction, which is 2.4 kilonewton pointed upward. So kalau kita redraw dekat sini, it would be 2.4 kilonewton pointed upward. Tapi we are not sure where is the point of application. Okay, kat hujung sini ke, kat sini ke, kat sini ke, kat sini ke, kat sini ke. So let's just assume the point of application is over here. Okay, let's just assume the point of application is at a certain distance. So the reference point yang kita nak measure is in reference to point O. Okay, so point O is over here. So let's say the unknown distance to be D. Okay, the unknown distance relative to point O to be D. So macam mana kita nak calculate D ni? Okay, apa yang kita boleh buat adalah kita buat comparison di antara free body diagram untuk gambar rajah di sebelah kiri dengan free body diagram untuk gambar rajah di sebelah kanan. Dalam erti kata lain, gambar rajah sebelah kiri ni is actually the original system lah, the original free body diagram. Okay, whereas the figure on the right is actually the simplified free body diagram. Okay, it's the same system but it's the simplified free body diagram. Okay, kalau you tengok dia punya load pun sikit lagi berbanding dengan load being subjected from figure 1. Okay, so in order for us to get the value of D over here, to get the point of application of the resultant force, apa yang kita boleh buat adalah kita buat comparison di antara figure 1 dan figure 2 dengan menggunakan persamaan moment. So how do we do that? Okay, basically based on these two figure, so you kena apply moment summation and buat comparison di antara gambar belah kiri dengan gambar belah kanan. Sebab kita boleh katakan bahawa the system or the free body diagram on the left is actually equivalent to the free body diagram on the right. So, kita buat comparison. Comparison apa yang kena buat? Okay, in the moment summation, assuming the counterclockwise to be positive, so kita nak buat comparison the resultant moment, okay, the resultant moment from relative to figure O, dia mestilah sama dengan summation of moment relative to point O. The equation on the left, okay, moment ni is based on figure 2. It is based on the simplified free body diagram, whereas the equation on the right part is in reference to the figure number 1 or the original free body diagram. Okay, so you tengok satu-satu. So from the simplified free body diagram or from figure nombor 2 ni, convert all the external load into an equivalent moment. So recall, moment punya formula adalah moment sama dengan F darab D kan. So you have to use this relationship to convert all the forces into an equivalent moment. So you tengok at the first load, apa benda force yang ada kat sini on the second figure, on the simplified free body diagram. The first one is the 2.4 kilonewton pointed upward. So kalau kita nak convert this 2.4 kilonewton jadi moment, kita kena multiply dengan distance. So the magnitude of the force is 2.4 kilonewton. Distance dia kita tak tahu. So let's just put the D. And the direction, okay, direction is counterclockwise. So in our equation, it becomes positive. Okay, so the next one adalah this 4.8 kilonewton. Kalau you tengok this load, kita assume it to be position in line with the rotation point. Okay, so bila it passes through the rotation point, maknanya tak ada distance. Bila tak ada distance, it means that this 4.8 kilonewton will not create any moment. Okay, so that's it. So there are two forces, two loads, kita dah convert into an equivalent moment. Alamak, terhilang pula D dia tadi kan. Okay, so now you buat comparison dengan the moment produced from the original free body diagram, from figure 1. So tengok dekat figure 1, you convert every single force into an equivalent moment. So let's start from this 4 kilonewton, this downward force of 4 kilonewton. So magnitude dia adalah 4 kilonewton. What is the perpendicular distance? Kita nak convert dia kepada moment, kita kena darabkan distance. The perpendicular distance is 1.5 meter. What's the direction of the moment produced by this 4 kilonewton? This would be clockwise. So therefore in our equation it become negative. Okay, yang ini dan this 4 kilonewton dan kita dah convert dia jadi moment. Okay, don't forget untuk convert this 8 kilonewton juga jadi moment. So recall from the previous exercise, actually kita dah dapat the magnitude in the x and the y direction. So if I may rewrite balik dia punya equation, the magnitude in the x direction is 8 darab 3 per 5. And in the y direction is 8 darab 4 per 5. Okay, so now again accordingly you kena convert every single force jadi moment. So tengok force apa yang ada kat sini. There's one force in the upward direction. Magnitude dia adalah 8 darab 4 per 5. Perpendicular distance dia, kalau tengok perpendicular distance dia from here to here, dia ada 1, 2, 3. Okay, so saya pun boleh buat lah 3 kali 1.5. Okay, so what's the direction of the moment? It's a counterclockwise direction. So therefore in our equation it becomes positive. Okay, that's done. Kita dah convert the positive y force into moment. So next kita convert this part pula. Okay, our brother kat sini. The magnitude of the force pointed to the right adalah 8 darab 3 per 5. So kalau kita nak convert kepada moment, kita kena darab dengan distance. So kalau you tengok very carefully, you zoom up dia, distance dia must be perpendicular distance relative kepada line of force kan. Perpendicular distance from rotation point pergi line of force. So this is the distance that we want. So the distance in our case would be 0.5 meter. So you put that into your equation. So what kind of rotation produced by this line of force? Kalau dia ke kanan, so kalau you draw dia punya moment direction, it will be in a clockwise direction. So therefore in our equation it becomes negative. Okay, so basically you dah convert 3 forces into an equivalent moment. This 4, this 8 dari 45 dengan this 8 darab 3 per 5. Ada lagi tak moment dalam sini? Jangan dilupakan satu moment. Jangan dilupakan ada satu lagi moment kat sini. Which is a magnitude of 15 kilonewton meter in a clockwise direction. So you tak payah darab dengan distance ke apa, because it is already in a moment punya magnitude. It is already the magnitude of moment. So you letak dalam equation you this 15 kilonewton meter. Clockwise or counterclockwise? Tengok, it is clockwise direction. So kalau clockwise it will be negative in your equation. So ada lagi tak moment dalam sistem ni? Tak ada. So you can actually proceed with your calculation. So kalau you tengok equation yang you dah generate tadi, the set of equation on the left side is in reference to the simplified free body diagram or based on figure 2. The equation that you generate on the right is actually the moment referring to the original free body diagram ataupun from figure 1. So you are making comparison of the moment produced on the left side of the figure dengan on the right side of the figure. Okay, so quite conveniently you just sambung je you punya problem solving sini. So 2.4D. So you guna calculator, you kira berapa total ni semua. So kalau tekan-tekan-tekan, you akan dapat a value of 5.4. So there's only one unknown, which is D. So quite conveniently you boleh dapat D dengan bawa 2.4 sini ke sini, dia akan jadi bahagi So the distance would be 2.25 meters. So that, my friend, is how you locate the position of the resultant force along the beam. Okay, so all the best.